Alright class, today we're going to start our new unit, which are exponential and logarithmic functions. Today we're going to just look at what an exponential graph looks like and the equations that give us these graphs. So we're going to complete the table here. If 2 is raised to the negative third, that's 1 over 2 cubed, or 1/8. If I raise it to the negative second, it flips it down, you get 1/4, and then you should start seeing a pattern. You're multiplying by 2 every time. Anything to the 0 power is 1, 2 to the first is 2, and then 4, and then 8. So let's look and see what that looks like. So negative 8th is like right there, negative 4th is right there, half is here, 1, 2, 4, okay, and then 3 is 8. Okay, so when you graph these, what happens is that no matter what number you put in for x, it'll never get to 0. So there's actually a horizontal asymptote right there. And now the opposite is true of 1. Think about this. If I raise this to the negative third, it flips it up and becomes 2 to the third, which is 8. Then it's 4. Then if I flip it up, it's 2. Then if I put that to 0, it's 1. And then if I keep it the same, it's 1/2. If I square it, it's 1/4. And if I raise it to the third power, it's 1/8. So, negative 3, 8. Negative 2, 4. Negative 1, 2. And then obviously 0, 1. And then 1/2, 1/4, 1/8. So, this one starts off high and goes down. Again, it'll never hit 0 though, because if you raise this to like 1,000,000, it'll still be a decimal. Alright, so those are the basic exponential forms for a base of either 2 or 1/2. We call the first one growth. First of all, exponential function has the form number times the factor raised to a power, where you cannot have a 0 for a and the base is positive other than 1. Okay. So an exponential function is, and when b is greater than 1, like we saw, it increases. We call that the growth factor. And again, for the parent function, this point will always happen, and so will that. And actually, so will negative 1, 1 over b. The domain for these is that x is all real numbers. But the range is that you're greater than 0, because it's never actually going to hit. Same thing for this one. This is called the decay factor. That happens when b is a fraction less than 1 but greater than 0. The domain for these is still x is all real numbers, but the range actually is also still greater than 0. The difference is it goes down instead of up, but it still will not cross the 0. So all the values will be above the y equals 0 line. So we're going to sketch these. Now you can use your calculators for these. I'm going to just do them without the calculator because I have them already done. So I'm going to sketch the parent and then the regular. So the parent is 3 to the x. So 3 to the x has the points. When you put 0 in, you're at 1. When you put negative 1 in, you're at 1/3, 1/9. When you put 1 in, you're at 3. When you put 2 in, 3 squared is 9. 4, 6, 8, 9. And when you put 3 in, you're all the way at 27. So that would be 10, 24. Okay, it's not even on the graph. So it's like up here. So here's my parent graph. Okay, so what this 1/2 does is it compresses it. This 1/2 compresses, which means we didn't really talk about this. It means you multiply the y values by 1/2. So all that does is say, well, at this point now we're at 1/2. This point was at 3, so now it's at 3/2. This point was at, I believe, 9, so now we're at 4.5. So that point comes down here. This point was at 27. Now it's at 12. No, that's not right. 13.5. So 13.5, 6, 8, 10, 12, 13.5. So all of these have gone down by half, so the final graph looks something like that. Alright, so it compressed it towards the x-axis a little bit. Okay? Alright, now we're going to do this one. We're going to start off with our parent graph, which we did on the front page. The parent I'll do in red. Again, 0, 1, 1, 2, 2 squared is 4, 3 squared is 6, 8, and then 1/2, 1/4, 1/8. So here's my parent. What this number means we reflect, I'm going to do both of these at once, reflect and multiply by 2, the y. So that means this point is at 1/2. It flips over and multiply by 2 becomes 1. This point's at 1. It flips over, multiply it by 1. It's now 2. This one's at 2. Double it. It's now 4. This one was at 4. Flip it over. It's at 4. Now double it. It's now at 8. And finally, this one was at 8. So you flip it over. 8. 10, 12, 14, and double it. Now it's at 16. So all of these get doubled. Alright, and then it still goes to 0 though. Okay, so again, these points are stretching away faster than these ones. We have to also talk about the domain and range for all these and the horizontal asymptote. Notice how the horizontal asymptote is always at y equals 0 unless there's a vertical shift. So y is equal to 0. Here there was no vertical shift, so again it's still y equals 0. For this one, the domain are always all real numbers. Same with this. It's all about the range. What's going on with the range? Well, here we have everything above the line y equals 0, so y is greater than 0. Here, the purple one is below 0, so we want everything where y is less than 0. Okay? Alright, so that's that one. Let's do number 5. I have to do the 1/4 graph. This will be a decay. So I'm going to do this first. So 1/4 to the 0 is 1, which is here. These go by, what are they called? By 2's it looks like. So that's 1. 1/4 to the negative 1 is 4. 1/4 to the negative 2 is 16. So 4, 8, 12, 16. And then 64. I don't know if I can fit 64 on there. Maybe we can. I don't know. 4, 8, 12, 16, 20, 24, 28, 32, 44, 48, and it's way up here somewhere. Okay. And then at 1, it's 1/4, which is really tiny, and then it's basically very tiny. So, oh, I should be dotting this because it's the parent. So there's the parent, there's some of the points that I like. Okay. So this is just saying multiply by 3. So if I multiply 1 by 3, it goes up to 3. If I multiply 4 by 3, it goes to 12. If I multiply 16 by 3, then it goes to 48, which I believe was near the top. So this was 8, 10, 12. 16, 20. It's like way up, it's up there. Okay, and then this one was at 1/1/4, so now it's at 3/4. So it kind of moved up faster, but okay, again, nothing really happened there. With the horizontal asymptote, and the domain is always all real numbers, and the range, again, we're always above y 0, so that's our range. Okay, this one's kind of more complex. You kind of work from the inside out. First I'm going to start with just the parent, which is 2 to the x, so I'll do that in red. We did this one already. It's when 2 to the first is 2, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. So 8, 10, 12, 14, 16. And then we have 1/2, 1/4, 1/8. Okay, so there's my parent there. Now I'm going to do the shift in the x first. Technically, you could do this first and then that, but since it's there, I'm going to shift 1 to the right. So that point goes there, that point goes there, that point goes there, that point goes there, and that point goes there. That's there, there, there. Okay, so now this blue dotted line is not the final answer. I just did the shift. So now we're here. Then the next step is I'm going to multiply everything by 2. Sorry, by 3. So this point gets multiplied by 3. It's at a y of 1. So now it's there. This is at a y of 2, so that goes up to 6. And this is at a y of 4 times 3 is 12. So 6, 8, 10, 12. And where's the other point? This one here is at 6, 8. 8 times 3 is 24. So we do another 4. No, these are all 1s. So 4, 8, 4, 8. So it's like up here. So that's the third. This is like right about, this is 1/2 times 3 is 3/2, so that's about there. 1/2 times 1/4, 3/4. So it's kind of doing the same thing, but it extends a little bit faster. And then finally, the last shift, we go down 4 with all these points, these green points. So this is a little sloppy, I know. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So these are all kind of down here. You should see that there's an asymptote here. The asymptote has shifted. And then this green point goes down 4, so it's actually back where it was. This one goes down 4. And somewhere like that. Okay, so then this looks like this. Alright, so that's how you kind of do all the transformations. It's a little sloppy, I know. But that's how you do them individually. The horizontal asymptote has changed to y equals not 0. I just wrote that. It's down now at -4. The domain is still the same, but now the range has changed. We have everything. The purple line is above y equals -4. Okay, so that's how you do the full transformation step by step. All right, we got a couple more. So we're going to start off with a base graph of 3 to the x, which is, again, at 0 it's 1, at 1 it's 3, at 2 it's 9, 4, 6, 8, 9, and then we have 1/3, 1/9, and yada yada yada. We reflect first over the x-axis. So all that means is that all these points come here and reflect. So that's at 9 down. 1, 2, 3, 4, 5, 6. There's that one. 1/3, 1/9. So there's the new graph. It flipped down. And then finally we move this graph that is the green graph down 2. So all these points move down 2. So that means the horizontal asymptote shifts down 2. So basically the y shift tells you where the horizontal asymptote is. In this case it's at -2. So that is the graph. There was no stretching, it just moved down 2. The horizontal asymptote is at -2. The domain is all real numbers. The range has to be less than -2 because we're going down. Okay, we have one more and then E. So this one we have a couple of shifts. In fact, we have a few we have to deal with. First, let's deal with the parent, which is 1/2 to the x. So that's again here, and then at 1, 1/4, 1/8, yada yada yada, it goes off to 0. when it's -1, it becomes 2. When it's -2, it becomes 4. When it's -3, it becomes 8. 6, 8. When it's -4, it becomes 16. 10, 12, 14, 16. Okay, so there's the parent. That's our starting graph. The next thing you should do is move it to the right 2. So everything moves 2 to the right. Okay, so there's the new parent graph. Next, you have to do the vertical stretch. You do not do the movement in the y until last. So we're now taking these blue points and multiplying them by 3. So this one was at 2, so it's now at 6. This one was at, it should be here actually. Forgot to move that one over. This blue one should be right here. Okay. So at 1 times 3 is 3, so this is up here. 1/2 times 3 is 3/2. 1/4 is 3/4, and then we go from there. Okay? And then this point is multiplied by 3 as well, and that's at 8, so it's up to 24. Is at 16, so that's going to be way up here. Okay, so now we're at this graph, and the only thing you have to do from this graph then is shift it up 1. So my final graph will be in green this time, so every point gets shifted up 1. Then we're done. So the horizontal asymptote is there. So that's shifting the stretch graph up 1, and it's going off to y equals 1. So the horizontal asymptote is y equals 1 because that's what was shifted up. Domain is always all real numbers, and the range here is y has to be bigger than 1 because the green graph is higher than that. So that's how you do some transformations. Last thing, what is e? Many problems that occur in nature require the use of an exponential function whose base is a certain irrational number. Like pi, the number has its own symbol, the letter e. Use the graphing calculator to approximate it. Basically, if you type in e to the first in your graphing calculator, you get 2.718. And then to do that function, it's very similar, so that's like the base. So if we do e to the x, the graph of that looks like this, 2.7, and then that one's like 2.78 to the second is like 7 point something. So it's the same looking graph, it just has a different base. And that's the parent function for e to the x, which we will use a few times. Okay, so that was just graphing today. You'll get better at this. You can use your calculators at first and just plot the points. I was just kind of doing them by hand because it would take too long to do the calculator on here. So, all right, good job.